Hi, good morning, everyone. Thanks for allowing me to present our paper in this special way. My name is Chen Xiang from the National University of Singapore. As online users, I believe we all have rich ad experience. Someone may like the ad, someone may don't care about the ad, or someone even get annoyed by the ad. In this paper, we will discuss how can we use the multimedia techniques to improve the effectiveness of existing advertising system. Generally speaking, online advertising can be classified into two categories, sponsored search and display ad. In this paper, we mainly focus on display ad. Display ad is also called banner ad. It refers to simple text or image ad embedded somewhere within the web page. In this example, there are two display ads, one is here and one is here. Since we have already discussed the single-slot web page advertising in our SIGIR paper this year, now we will focus on multi-slot scenario. As we propose to integrate multimedia matrix into real-time bidding, we will explain our framework as follows. Why we need multimedia matrix? This is because online advertising has been viewed as an economic issue where the publisher's revenue is the primary concern. However, the user and the advertiser's benefit has been rarely concerned. So we use multimedia matrix to measure the benefit of the stakeholders. And what are the multimedia matrix? In our framework, we introduced the three multimedia matrix: contextual relevance, visual saliency, and image memorability. We will give a more detailed description later. And how will we integrate the multimedia matrix to real-time bidding to achieve the optimizing of the trade-off among all stakeholders? Nowadays, the majority of display ads are serviced through the real-time bidding. To figure out how can we improve it, we first need to understand how it works. Here is a simplified description of real-time bidding process. When a user clicks on web page URL, on one hand, the publisher's content server will prepare the web page content and download it to the user's browser. On the other hand, the publisher's ad server will post an ad request through the ad platform with the user's profile and the web page information. And then, advertiser will respond to this request with a bid price for the ad impression. Usually, the ad with the highest bid price will be displayed to the user. Although real-time bidding has been proved to be successful, there are still some limitations. Here are some shocking but true statistics from the marketing data. First, most displayed ads are irrelevant to the host web page, which will result in no engagement of the user. And second, it has been found that young adults tend to ignore the ad. It is said that in the US market, more than half of displayed ads are unviewable or viewed by fraud users. And also, recent eye tracking experiments said that users tend to ignore the ad located at the bottom and the right of the web page. And third, competitive ad may occur. We define competitive ad as follows. Two ads are competitive if they share the same topic but belongs to different company. For example, Apple iPhone 7 is competitive to Samsung Galaxy because they are all about a mobile phone, but they belong to different company. The advertiser get harmed since they pay for the impression, but they cannot deliver their product information to the user. The fundamental issue of display advertising is to select a proper ad among a set of candidates. However, this is not an easy task. We classify most existing works into three categories. From the economic point of view, the research topic involves with most research works view online advertising as an economic issue. They investigate how to sell the ad slot to the advertisers effectively, such as the GSP auction model, VCG auction model. From the multimedia point of view, existing works can be classified into contextual advertising and targeted advertising. In contextual advertising, the selected ad is relevant to the web page content, while in targeted advertising, the ad is relevant to the user's profile. From the psychology point of view, researchers mainly investigate users' attitude and behavior on the displayed ad. Above all, we find that most existing works mainly focus on a particular domain of knowledge. Through analyzing the psychology literatures, we find that integrating multimedia and auction series brings an opportunity to improve the effectiveness of display advertising. Here is our proposed framework. After a user clicks a web page URL, we first follow the existing ad process to form the auctions. In existing framework, the second price auction model will select the ad with the highest bid price. However, what makes our framework different is that we introduce more factors to select a proper ad, and we further consider the interaction among ads. For example, if an ad about iPhone is selected for ad slot A, we will not select a Samsung mobile ad for slot B. We argue that the best ad should not only generate the best price, but also fit the context well. In this regard, all stakeholders' benefits are considered. We view the problem as an optimization problem. Suppose that each ad slot will generate a certain amount of benefit. We want to maximize the sum of the benefit of all slots. The constraints are: first, all ad slot has to be occupied by one and only one ad. And second, the ad slot J must be occupied by the ad who bid for that ad slot. And third, each selected ad pair has to meet the specified constraint, such as no competitive ad occurs. We evaluate the benefit of each selected ad from 6 dimensions: revenue, utility, click-through rate, memorability, relevance, and saliency. We choose revenue since revenue is always the major concern. For each advertiser, we define his utility as his value minus his paid price. It indicates advertisers' cost saving in the auction, and the larger the utility is, the happier the advertiser will be. We consider click-through rate since click-through rate can partially indicate the popularity of the advertisement. We introduce image memorability because it indicates how likely the user will remember the ad in a long term. The image memorability can be viewed as a long-term benefit for the advertiser. We consider contextual relevance since the market has shown that contextual relevance can improve the click-through rate and also maintain users' ad experience. We introduce visual saliency because it can increase the probability that the user will notice the ad. Among all the 6 variables, the first 3 are commonly used in auction series, and the last 3 are introduced from multimedia. To calculate the benefit of each auction, we first need to deal with the economic issue. For example, in this auction, there are 5 bidders with bid price from 8 to 4. We extend the second price auction and decide their paid price. Their paid price are from 7 to 4 to the reserved price. According to the definition of utility, we minus bid price with the paid price to obtain the utility. And then, we use the state-of-the-art multimedia techniques to obtain multimedia variables. We use linear combination to obtain the benefit of each ad if it is selected for a specific slot. since the weight represents the preference of each variable. Now, the key issue is how to determine the optimal weight. We formulate the problem as an optimization problem and propose to obtain the optimal weight from the historical data. Since the publisher already knows that his revenue will decrease when using our model, there must be a threshold of how much he can tolerate, and it is the same for the other variables. We view the maximization of the benefit of all nodes as our objective function, and the changes of variable and the threshold of variable changes as constraint. In this model, the equation 6 indicates the changes, the constraints on revenue changes, and equation 7 indicates the changes, the constraint on changes of other variables. In our experiment, we use two types of dataset to evaluate the effectiveness of our framework. The multimedia dataset represents the interaction between the publisher and the user, and the auction dataset represents the interaction between the publisher and the advertiser. It should be noted that in our multimedia dataset, we find that the total number of impressions of each website is much larger than the number of unique advertisements. In other words, some ads keep appearing from time to time. The repeat display advertising strategy can enforce users' memory, but it will also become a source of intrusiveness. As we mentioned before, the ads are irrelevant to the web page, and the ads are easily overlooked. We quantify these findings through analyzing our multimedia dataset. As we can see, the memorability score of most ads is above 0.7, which indicates that the ads are designed to be memorable by the advertiser. And in this figure, the context relevance score is pretty low. And even worse, most displayed ads are non-salient. We also provide a statistic about competitive ad pair in our dataset. We consider three scenarios. First, two ads with the same landing page. This means these two ads are the same ad. And second, two different ads belong to the same company. And third, two competitive ads. As we can see in this table, scenario 1 is a typical strategy used by advertisers to enforce users' memory. And also, competitive ad still occurs. Considering the large scale of ad network, the effectiveness of the whole system will be affected by the competitive ad. Here is an experimental result. So let's take a look at the figure on the left. As we know that the publisher needs to sacrifice a certain amount of revenue in trade of improvement on the other variables. In this figure, when the threshold of revenue loss is small, by the way, the X indicates the threshold of revenue loss. And we can see that when the threshold of revenue loss is small, there will be low changes. This is because our weight determination model is not able to find a solution. In other words, the publisher doesn't want to lose revenue, but he is greedy in improving other variables. And when the threshold of revenue loss increased, the other variables increased to various degrees. To be specific, if the publisher says that the maximum loss of his revenue is around 5%, and he don't want to lose performance on other variables, so we would suggest that when use our framework, the revenue loss is around 3.6%, and the visual saliency will improve by 8%. And also, it should be noted that in this example, the relevance and memorability are not improved, This is because the optimal weight changes with the threshold. The publisher can achieve improvement on the relevance if he assigns the corresponding threshold with a larger value. So in this paper, we propose to use multimedia matrix to real-time bidding to improve the effectiveness of display advertising. As the best of our knowledge, we are one of the few works that integrate multimedia with auction theory. In our previous work, which has been accepted by SIGIR, we focused on single-slot web page. In this paper, we focus on multi-slot web page. The differences are the multi-slot can be viewed a more generalized framework when compared with the single-slot web page. And in single-slot scenario, the ad selection is viewed as a ranking problem, while in multi-slot scenario, the ad selection is formulated as an optimization problem. In the future, we will investigate how our framework will change the advertising ecosystem in the long run. From the supply and demand theory, we argue that the publisher's revenue will decrease in a short term, but it will increase in a long term. But how long will it take? It will be an interesting topic. And from the game theory, we will investigate whether the advertiser will change his behavior or not. So that's all about the presentation. Thank you.